The sun hangs low above the central plains of Australia, casting long ochre shadows across a landscape scorched by time. The grasses here, baked into brittle spears by days of relentless heat, whisper under the hot wind, and between their shifting blades, movement begins. At first it's just a tremor, a distant vibration in the air, felt more than seen. Then, rising over the low ridge, the unmistakable silhouette takes form, powerful hind limbs, elongated feet, and a muscular tail held low like a counterweight. A red kangaroo crests the slope, pauses, and surveys the sunlit basin below. The kangaroo is not walking. It doesn't need to. It bounds, a singular form of motion known as saltatory locomotion, perfected over millions of years. With each effortless leap, it covers 6 to 9 meters of open ground. The tendons in its hind legs act like biological springs, storing and releasing energy with incredible efficiency. Even its tail, thick and prehensile, contributes to balance and propulsion. Despite its large frame, males can exceed 90 kilograms and stand over 6 feet tall. The kangaroo moves with a rhythmic grace, a visual contradiction to the harshness of its environment. Around it, a loose group of kangaroos, a mob, grazes. They are cautious but not panicked, always scanning. The Australian outback does not forgive carelessness. Dingoes, the continent's apex mammalian predator, roam this territory. Though they rarely take on a healthy adult kangaroo, juveniles and the sick are fair game. Survival here depends not just on strength, but on awareness. The large, forward-facing ears of the kangaroo pivot like independent radar dishes, mapping the soundscape for danger. Their eyes, set high and wide, offer near panoramic vision, an evolutionary necessity in such open terrain. Females, smaller and lighter than males, forage near the edges of sparse tree cover, their joeys never far. In one mother's pouch, a nearly invisible head peeks out, furless, blind and embryonic, though the joey is already several weeks old. Unlike placental mammals, kangaroos give birth after just a month of gestation. The newborn, smaller than a peanut, must crawl unaided into the mother's pouch to latch onto a teat, where it will continue to develop for another 6 to 8 months. Remarkably, female kangaroos are capable of producing 2 types of milk simultaneously, one suited for a pouch-bound infant and another for an older joey still nursing outside. They can even pause a pregnancy mid-development, a phenomenon known as embryonic diapause, allowing them to align births with environmental conditions. As the afternoon heat deepens, activity slows. Kangaroos are crepuscular, most active during the cooler hours of dawn and dusk. But even in stillness, their physiology continues to adapt. Their bodies are optimized to handle dehydration, conserving water through highly efficient kidneys and producing dry, pellet-like feces. On especially hot days, they lick their forearms, a behavior that seems odd until closer inspection reveals the dense network of blood vessels beneath the skin. As the saliva evaporates, it draws heat from the bloodstream, acting as a natural coolant. Occasionally, tension ripples through the mob. A large male, his chest broad and scarred from previous contests, stands upright. His posture is more than casual stretching. It's a display, a warning. Mating season turns the otherwise indifferent kangaroo into a competitor. Fights between males, or boxing matches as they are often called, are far more strategic than the name suggests. Using their forelimbs for balance, they grapple and shove, then lean back on their tails to deliver powerful kicks with clawed feet. Injuries are common, fatalities are rare. Dominance, not destruction, is the goal. Beyond the mob, a wedge-tailed eagle circles high overhead, its massive wings nearly silent in the rising thermals. Though it rarely preys on adult kangaroos, it is a threat to the young, and another reminder that the kangaroo lives surrounded by subtle, patient dangers. Even the land itself is a challenge. Much of central and western Australia consists of nutrient-poor soils. Grasses are tough, fibrous, and of low nutritional value, Yet the kangaroo's specialized molars, broad and flat, ideal for grinding, allow it to extract what little sustenance is available. As twilight approaches, the landscape shifts again. Long shadows stretch into silhouettes. Temperatures dip. The kangaroos begin to move, some to graze, others to travel. Where fences have not cut across ancestral paths, they follow invisible routes etched by generations. A few leap across dry creek beds and eroded tracks with fluid ease. What appears as random movement from afar is often purposeful, a search for recently burned ground where new shoots may be sprouting, or a return to known waterholes that have persisted through dry seasons. Water remains a limiting factor. In arid zones, rainfall is sporadic and unpredictable. Yet kangaroos endure where others cannot. They can survive on minimal moisture, drawing enough hydration from grasses during drought. In extreme cases, they will dig shallow wells, uncovering groundwater sources just beneath the surface. A behavior shared with indigenous Australians who observed and mimicked kangaroo survival techniques long before modern ecology. It's easy to view the kangaroo simply as a symbol of Australia, of the outback, of athleticism. But symbols can simplify what is, in truth, a finely balanced ecological participant. Kangaroos are not just inhabitants of the landscape, they help shape it. Their grazing patterns influence vegetation growth, and their movements disperse seeds across wide ranges. In some regions, their numbers swell to unsustainable levels, leading to debates over culling and conservation. A paradox born from the clash between ancient survival strategies and modern land use. Despite their deep evolutionary roots, kangaroos are not relics of the past. They continue to evolve, to adjust. In urban fringes, eastern grey kangaroos now live closer to human development than ever before. They forage in golf courses, cross highways, and raise their young near suburbia. These new frontiers pose dangers: collisions, entanglement in fences, habitat fragmentation. But they also reveal a creature remarkably capable of navigating a changing world. As night fully descends and the last orange hues fade from the sky, the kangaroo mob disperses into the shadows. Their silhouettes blend with the terrain, now cool and dark. Another day ends in the red center, where life leaps forward not through brute force, but through quiet endurance, elastic strength, and generations of adaptation. The kangaroo does not dominate this land. It survives it, and in doing so, it becomes one of its most enduring masters. The canopy of the eucalypt forest barely stirs in the early morning calm. The light is diffuse, filtered through long ribbons of mist that cling to the tree line. Overhead, the branches form a loose lattice of shadows and movement, but it is not the rustle of birds or the scurry of possums that catches the eye. Instead, nestled high in the fork of a grey box eucalyptus, a solitary koala sits motionless, a lump of fur draped over bark, its shape barely distinguishable from the tree itself. To the casual observer, it may seem lifeless, but then a slow blink, a twitch of a rounded ear, confirms its quiet vigil. Koalas are often described in reductive terms: sleepy, docile, adorable. While not entirely inaccurate, these descriptors miss the deeper complexity of an animal finely adapted to a singular and unforgiving ecological niche. Native to the coastal and inland forests of eastern Australia, koalas depend entirely on eucalyptus trees, not just as food, but as shelter, refuge, and infrastructure. With over 600 species of eucalyptus on the continent, koalas feed on only a few dozen. Within those, individual preferences emerge, often passed from mother to offspring. A particular tree may be favored for the mineral content of its leaves or for its microclimate, and a single koala might defend a well-known cluster of preferred trees for much of its life. Their diet presents a puzzle. Eucalyptus leaves are tough, fibrous, and filled with bitter compounds, terpenoids and phenolics, that deter nearly every other herbivore. Koalas possess one of the most specialized digestive systems in the marsupial world. An enlarged cecum and extended colon house, a dense microbial community that slowly breaks down the toxins and extracts scant nutrients. The process is inefficient, which explains the koala's famously low-energy lifestyle. Sleeping for up to 20 hours per day is not an indulgence. It's a physiological necessity. Every movement, every climb is weighed against the high cost of burning calories. In the stillness of midday, the forest is subdued. Cicadas drone in a rising and falling chorus. The wind carries the sharp medicinal scent of eucalyptus oil, potent enough that it can suppress the undergrowth. Above, the koala begins to stir. Its fur, grey with a pale underside, ripples as it shifts position, large paws gripping the bark with curved claws. The forelimbs, short but powerful, are tipped with two opposable digits, allowing for a vice-like hold. The hind limbs, longer and muscular, aid in climbing, while the rear feet feature a grooming claw, essential for removing debris and parasites from dense fur. Despite their reputation for lethargy, koalas are capable climbers. The trunk is scaled with deliberate slowness, back legs pushing, front limbs pulling in a coordinated rhythm. When descending, they shift backward cautiously, hugging the bark, always maintaining contact with at least 3 limbs. On the rare occasions that they must cross open ground to find new territory or during mating season, they become vulnerable. Their gait becomes awkward and slow. Predators such as dingoes or powerful owls pose a threat, especially to juveniles, but the more frequent danger is man-made: dogs, fences, and vehicles. The young, called joeys, begin life the size of a jelly bean. After a 35-day gestation, they crawl unaided into the mother's pouch, where they latch onto a teat and remain for the next 6 months. Even after emerging, they cling to their mother's back, learning through contact. As weaning approaches, the mother begins producing a unique substance, pap. It is a soft, semi-digested fecal matter, rich in the bacteria needed to process eucalyptus leaves. The joey consumes this to seed its own gut microbiome. Without pap, it would not survive the transition to solid food. Koalas are largely solitary animals. Their social system is defined not by pack or herd dynamics, but by overlapping home ranges. Males control larger territories, which they scent mark using a gland on their chest. During breeding season, they become more vocal, emitting a guttural bellow that echoes through the forest with surprising volume. This call, which serves to attract mates and warn rivals, is at odds with the otherwise subdued presence of the species. It is also one of the few times a koala intentionally breaks its cover. The forest offers some protection, but only in its continuity. Habitat fragmentation has become the central challenge to koala survival. As eucalyptus woodlands are cleared for agriculture or urban development, populations become isolated. The effects are compounding. Increased competition for fewer resources, greater exposure to predators and vehicles, and reduced genetic diversity. Unlike generalist species that can shift habitats or diversify diets, the koala's specialization leaves little room for adjustment. Climate change exacerbates these pressures. Higher temperatures and frequent droughts reduce the moisture content of eucalyptus leaves. Traditionally, koalas obtain nearly all their hydration through foliage. But in recent years, behavior has shifted. Individuals have been observed drinking directly from water sources, a rare behavior that suggests increasing environmental stress. Dehydration, combined with poor nutrition, weakens immunity, making koalas more susceptible to diseases such as chlamydia, which now affects large portions of wild populations. Even so, the koala endures. In protected areas where trees are healthy and corridors remain intact, populations remain stable. There is resilience in their strategy, not through adaptability but through refinement. Every detail of the koala's life, from its microbiome to its sleeping posture, represents an accommodation to a difficult diet and a complex environment. Its slow metabolism is not a flaw, but a controlled burn, calibrated to extract survival from scarcity. Back in the branches, the koala has resumed its near-motionless vigil. Its head nods slowly with the rhythm of respiration, eyes half-lidded, ears twitching occasionally at the sound of rustling leaves or distant calls. It does not leap, hunt, or chase. It does not need to. In a world filled with energetic predators and opportunists, the koala has carved out a role through patience, precision, and extraordinary biological partnership with one of the world's most chemically defended trees. As the day fades and shadows lengthen beneath the forest, the koala remains high in the canopy, limbs wrapped around the trunk, a creature suspended between sleep and survival. It is not dramatic in its motion, but in its stillness, a specialist balanced perfectly against its environment. The creek is quiet in the first blue-grey light of dawn. Mist coils above the water like breath held close to the surface, swirling gently before it lifts into the overhanging branches. On both sides of the bank, ferns glisten with condensation, their fronds heavy and motionless. The forest here, tucked deep into the temperate reaches of southeastern Australia, is still damp from the previous evening's rain. Every rock along the edge of the stream is slick with moss. The only movement comes from the subtle ripple of current winding around submerged logs and root-knotted shallows. Then, without a sound, the water is broken. A small dark shape glides just beneath the surface. Its movement is smooth but purposeful, alternating between submerged darts and short bursts to the surface for breath. From above, little is visible beyond the faint wake it leaves behind, a ripple expanding out across an otherwise undisturbed pool. But beneath the surface, the platypus is busy, sweeping its head from side to side, eyes closed, relying entirely on its most peculiar and astonishing feature, a bill that can sense the invisible. The platypus, Ornithorhynchus anatinus, defies categorization. At first glance, it appears cobbled together from spare animal parts. The flat, rubbery bill of a duck, the dense fur and webbed feet of an otter, and a broad, paddle-like tail reminiscent of a beaver. Yet despite its strange appearance, every element of its anatomy is purpose-built for survival in a narrow freshwater niche. The bill, so often compared to a bird's, is not rigid keratin, but a soft, pliable organ filled with thousands of electroreceptors. These receptors allow the platypus to detect the faint electric fields generated by the muscle contractions of prey, a feature found in few other mammals and none with this degree of refinement. As it swims, the platypus closes its eyes, ears and nostrils, completely surrendering to the guidance of its bill. In the dim, sediment-clouded water, vision would be of little use anyway. Instead, it navigates by sensing the signature pulses of invertebrates hidden under rocks or burrowed in the silt. With astonishing accuracy, it pinpoints small freshwater shrimp, insect larvae, and even tadpoles, scooping them up in quick motions before stashing them in cheek pouches to chew on later at the surface. It is not just the bill that distinguishes the platypus. The animal's reproductive biology is a holdover from a more ancient evolutionary branch. It is one of only 5 living monotremes, egg-laying mammals, all of which are found in Australia and New Guinea. The female platypus lays 1 to 3 leathery eggs in a nest deep within a riverside burrow. The burrow, often concealed among tangled roots or beneath overhanging banks, can stretch several meters into the earth. The entrance remains narrow and discreet, just wide enough to pass unnoticed by predators. Inside, she lines a chamber with wet leaves and grasses collected from the forest floor, maintaining a humid environment necessary for incubation. The eggs hatch after about 10 days. The young are born blind, hairless and dependent. Yet unlike reptiles or birds, they are fed milk, though the platypus has no nipples. Instead, the mother secretes milk through pores in her skin, which pools along grooves in her abdomen. The hatchlings lap it up directly, sustained for months before venturing outside. Even among mammals, the platypus pushes boundaries. Males possess a spur on their hind legs capable of delivering venom. a rare trait in mammals and unique among monotremes. The venom is not lethal to humans, but it causes excruciating pain and swelling that can persist for days or even weeks. The function of this weapon is not defense against predators, but dominance among rivals. During breeding season, males use the spur in fights, likely to deter competition for access to mates. Outside of this seasonal aggression, platypuses remain solitary, with overlapping territories but minimal interaction. The platypus's fur is dense and waterproof, finer than any wool, insulating it against cold water temperatures. Air is trapped close to the body in 2 layers of fur, allowing the animal to maintain a stable core temperature even in near-freezing streams. On land, it appears clumsy and awkward, its webbed forefeet folding back to expose small claws for digging or walking. But in water, where it spends most of its active hours, the platypus is elegant, agile, responsive, and fluid in every motion. Despite its highly adapted nature, the platypus faces serious threats. Urban expansion has fragmented its habitat, and pollution, sedimentation, and reduced water flows from dams and agriculture have degraded the quality of its freshwater ecosystems. Platypuses are sensitive to environmental disturbance. Plastic waste, fishing lines, and illegal traps are especially dangerous. The species does not tolerate prolonged drought well. As creeks dry and aquatic prey disappears, they are forced to travel between pools, exposing them to predators like foxes and dogs or to dehydration. In some regions, disease adds another layer of stress. A fungal infection known as mucormycosis has emerged in Tasmania, causing ulcerations that weaken infected individuals and reduce their survival chances. Though its spread remains limited, it signals the fragility of even well-adapted species when ecological pressures mount. Still, the platypus continues its silent patrol of the creeks and backwaters, where few others can thrive. Its ancient lineage, tracing back more than 100 million years, carries with it a remarkable record of endurance. It has persisted through climate shifts, continental drift, and mass extinctions. That it survives today is not an accident of biology, but a consequence of evolutionary ingenuity, compressed into a compact, elusive form that rarely reveals itself to casual observation. Back on the bank, the mist has begun to lift. Sunlight now reaches the water in slanted beams, reflecting off the slow-moving surface. The platypus surfaces briefly, releasing a few bubbles as it chews through its cached prey. Water drips from the curve of its bill down the fine fur of its chest. Then, with a push of webbed feet and a subtle flex of the tail, it disappears again into the shadows beneath a half-submerged root. What seems bizarre to us, the combination of avian, reptilian, and mammalian features, is in fact a streamlined solution to the demands of its habitat. The platypus has no need for conformity. It survives not by fitting in, but by exploiting the margins that others overlook. It is a creature shaped not by compromise, but by deep time, by isolation, and by the particular pressures of a continent where the rules of evolution have long followed a different script. In the quiet of the forest creek, it vanishes once more into the current, silent and strange, and exactly what it needs to be. The sun in Australia's central deserts does not simply rise, it dominates. Even in the early hours, the light carries a sharpness that cuts through shadow and sears the surface of the earth. Heat bleeds from the ochre sand and bakes the low shrubs that dot the flat horizon. The landscape here is spare, minimal, yet loaded with subtle intricacies, from the shallow tracks left by nocturnal animals to the way wind carves fine patterns into the dunes. On first glance, nothing seems to move, but closer inspection reveals a life form so well matched to its environment it may as well have grown from the very ground it walks on. At the edge of a gravel flat, where the red soil gives way to compacted sand, a thorny devil begins to stir. Barely 20 centimeters in length and armored like a creature from myth, the lizard moves with slow, jerky steps, lifting its feet high and pausing between each one as if testing the ground. Its gait is not clumsy, but calculated. This exaggerated movement, often described as a freeze walk, serves a purpose. It helps confuse predators by mimicking the shifting patterns of foliage blown by wind. To the untrained eye, the lizard is no more than a clump of desert debris, all angles and shadow. Known scientifically as Moloch horridus, the thorny devil is a marvel of form meeting function. Its entire body is covered in conical spines, each one a defense, not just from would-be attackers, but also from desiccation. The spines are not venomous, nor do they deliver any physical attack. Instead, they render the lizard nearly impossible to swallow. For predatory birds like the brown falcon or black kite, the idea of grappling with a moving pincushion offers little reward for the risk. Even snakes, which often rely on swallowing prey whole, struggle to find a vulnerable entry point. But the thorny devil's spines are more than a shield. They're part of a complex system for water collection. In an environment where rainfall is sparse and unpredictable, every drop counts. The devil's skin is structured with a network of tiny grooves that run between its scales, capable of drawing moisture through capillary action. When rain falls, or even when morning dew condenses on its back, water is channeled along these grooves, directed toward its mouth. The lizard doesn't need to drink in the conventional sense. Instead, it absorbs hydration through contact, a passive but highly effective method that allows it to survive where few vertebrates can. The desert is a place of extremes. By midday, surface temperatures can exceed 60 degrees Celsius, and much of the visible life retreats underground or into shade. The thorny devil, however, is uniquely adapted to cope with the heat. Its coloration shifts subtly throughout the day. In cooler hours, its skin appears more yellow and orange, helping it absorb warmth. As temperatures rise, it darkens, reflecting more sunlight and reducing thermal gain. This dynamic camouflage also helps it blend with the desert floor, which changes hue depending on the angle of light and the texture of the soil. Hunting is not dramatic, but it is relentless. The thorny devil feeds almost exclusively on ants, tiny, fast, and numerous. A single lizard may consume thousands of ants in a day, using a sticky, flicking tongue to catch them with surgical precision. Its head remains mostly still as it feeds, eyes scanning for movement while the tongue darts in and out of a small, narrow mouth. The choice of prey is not arbitrary. Ants, though small, are relatively rich in nutrients and moisture, but harvesting them in useful numbers requires patience and persistence. The thorny devil will often position itself near an ant trail and wait, expending as little energy as possible, then feed with efficient rhythm until sated. Its tongue is not the only subtle feature with a deeper purpose. The thorny devil's head sports a false second head, a knob-like protuberance behind the real one, ringed by large spines. When threatened, the lizard will dip its actual head between its forelegs and present the decoy. To a predator approaching from above, the false head is the only visible target, another layer of defense in an already formidable suite of adaptations. Combined with its erratic walk and camouflage, the overall effect is disorientation. A predator can't lock on to a clear shape, a weak point, or a predictable movement. The breeding season adds another dimension to this otherwise solitary life. In spring and early summer, males become more active, ranging farther in search of receptive females. Encounters are brief and functional. Females lay a clutch of 3 to 10 eggs in a burrow, excavated up to 30 centimeters below the surface. The nest is sealed and the eggs are left to incubate, relying on the steady subterranean warmth. After 3 to 4 months, the young hatch and dig their way to the surface. At birth, they are miniature replicas of the adults, fully formed and ready to survive with no parental care. Life expectancy in the wild hovers around 15 to 20 years, although few make it that long. Droughts can stretch for months, reducing ant populations and forcing the thorny devil to range farther across exposed terrain. Wildfires, intensified in recent years by climate variability, can strip entire habitats in hours. While their camouflage and low profile protect them from many dangers, they offer little defense against sweeping environmental changes. Introduced predators like feral cats and foxes, more adept at passing camouflage and more persistent in pursuit, present an ongoing challenge, particularly in marginal habitats. Despite these pressures, the thorny devil remains an icon of desert adaptation, its very presence a testament to the subtle, cumulative forces of evolution. It doesn't outpace danger with speed or overwhelm prey with strength. Instead, it survives by being overlooked, by blending perfectly with a harsh and fluctuating world, and by harvesting life from sources too small or scattered for most predators to bother with. As the sun begins its descent and shadows stretch longer across the sand, the thorny devil slows its movements. The air cools slightly, though the heat radiating from the ground lingers. It finds a shallow depression beneath a low shrub, aligning its spined body with the ridges of sand to minimize contrast. There, still and barely visible, it rests. The desert, while momentarily quiet, never fully sleeps. Wind will rise again. Temperatures will fall. Night will bring its own cast of threats and opportunities. But for now, the thorny devil endures, not by hiding from the elements, but by reading them, responding to them, and mastering the minute details that make survival possible in a place shaped by scarcity. In the stillness, it becomes once again indistinguishable from the land itself. Not a visitor here, but a native sculpted by heat, silence, and time. Below the surface, where sunlight fractures into shafts and fades into a shifting green-blue gloom, a presence moves with deliberate grace. It is not accompanied by noise, nor heralded by the sudden scatter of fish. The water, warm and glassy along Australia's southern coast, is calm above, but full of purpose below. A great white shark glides silently through the current, its body a seamless blend of muscle, instinct, and sensory perception, honed across millions of years. The shark does not thrash or rush, it conserves. Every flick of its powerful tail fin delivers precisely what is needed to maintain speed, to change direction, or to rise and fall through the water column. The great white Carcharodon carcharius is often reduced in the public imagination to its teeth. And indeed, the teeth are formidable, triangular, serrated, capable of puncturing thick flesh and slicing through bone. Rows of them sit along the upper and lower jaws, continuously replaced throughout the shark's life. But what defines the great white is not just its bite, it is its role. This animal, often feared for its rare interactions with humans, functions as a keystone predator. Its presence regulates populations of seals, fish, and even other sharks, maintaining the balance in complex marine ecosystems. It is not a rogue killer. It is an ecological necessity. Along the southern coasts of Australia, from Neptune Islands in South Australia to the deeper offshore reefs near Tasmania, great whites patrol in seasonal patterns. Their movements are not random. Individuals often return to specific locations year after year, navigating with the aid of environmental cues, temperature gradients, current flows, magnetic fields. These migrations may span thousands of kilometers, from temperate zones to tropical waters, yet the shark returns reliably to key hunting and breeding grounds. The waters here, rich with seals and sea lions, offer both challenge and reward. Pinnipeds are agile, fast, and alert, but a single successful hunt provides the kind of energy payoff that makes the chase worthwhile. Hunting in open water is not about pursuit. It is about timing, position, and control. The shark often approaches from below, hidden against the backdrop of deeper water. Its counter-shading, grey above, pale below, renders it nearly invisible to prey looking either up or down. As it rises, the shark remains in complete silence. Then, with a final burst of acceleration up to 40 kilometers per hour, it launches vertically, jaws open, and strikes with a precision that leaves little chance of escape. In some encounters, particularly around seal colonies, the momentum carries the shark fully out of the water, a display of raw power that lasts only seconds but speaks to extraordinary biomechanical capability. Despite their size, adults can exceed 6 meters in length and weigh over 1,000 kilograms. Great whites remain difficult to study in the wild. Their solitary nature, long-distance travel, and preference for deep or remote habitats present logistical challenges. Yet tagging and satellite telemetry have revealed complex behaviors. Individuals have been tracked moving across entire ocean basins, diving to depths of 1,200 meters, and returning with precision to known feeding sites. Some appear to follow specific thermal layers, adjusting their depth to remain within an optimal temperature band for hunting or digestion. What makes the great white truly exceptional is not just its physical attributes, but its sensory suite. Along its snout are the ampullae of Lorenzini, specialized organs capable of detecting minute electrical fields emitted by the movement of other animals. This ability allows the shark to locate prey hidden beneath the sand or to track faint biological signals in murky waters. Combined with acute vision, adapted for low light, and an olfactory system capable of detecting parts per billion of blood in seawater, the shark becomes more than predator. It becomes a biological sensor platform, tuned to a degree of sensitivity that few creatures can match. But there is vulnerability too. Slow to mature and producing few offspring, the great white shark reproduces via internal fertilization, with litters ranging from 2 to 10 pups. These young are born fully formed and self-sufficient, but face high mortality in their first year. Their growth is slow and maturity is delayed. Females may not reproduce until their teens or early 20s. This low reproductive rate leaves populations susceptible to overfishing, bycatch, and environmental changes. While protected under Australian law, great whites remain at risk from long-line fishing, illegal finning, and the degradation of prey populations. Misunderstood and often vilified, these sharks play a far more nuanced role than popular culture suggests. While attacks on humans do occur, they are extremely rare and almost never predatory in intent. More often, they result from mistaken identity. Surfers or swimmers silhouetted against the light resemble seals, especially in turbulent or unclear water. In most cases, the shark releases the victim after an exploratory bite, retreating rather than committing to the kill. These incidents, though tragic, represent anomalies rather than a pattern, yet they dominate public perception and policy. In recent years, new technologies, drones, underwater cameras, acoustic tagging, have allowed for a more detailed view of great white behavior. Individuals exhibit preferences for specific hunting techniques, respond to changes in temperature and current with surprising nuance, and even demonstrate what may be rudimentary social behavior, congregating in loosely defined groups during periods of high prey density. These findings challenge the stereotype of the lone marauder and suggest a more adaptable and intelligent animal than once thought. As the shark glides past the reef wall, a school of trevally splits to avoid its path. The shark does not accelerate or alter course. It is uninterested in the small, quick fish. Instead, it continues on, navigating by unseen cues, passing coral formations and drop-offs, moving between shadows and light. Its path is purposeful but slow, an energy-conserving patrol that may last hours. Far above, the surface glimmers. Below, a darker world awaits. The shark descends again, returning to the depths where it is most comfortable, where temperature is stable and visibility drops. There it waits, never still but always watchful. The great white shark is not a ghost, but it does haunt the edges of perception. Rarely seen, often imagined, its presence shapes not only the behavior of its prey, but the structure of the entire ecosystem. Seals feed differently when sharks are present. Fish shoals behave with tighter coordination. Even smaller sharks adjust their patterns to avoid encounters. This top-down control creates space for balance, for resilience. Remove the apex and the system begins to falter. In Australian waters, the great white remains a vital thread in the marine web, linking predators and prey, surface and seafloor, coastline and open ocean. It is not an artifact of the past, nor an obsolete remnant. It is a living force, tempered by evolution, essential to the rhythm of life in the sea. As it vanishes into the gloom once more, the stillness returns. The reef resumes its quiet noise and the water clears. But the balance for now holds, because somewhere beyond sight, the great white watches. The morning mist is still lifting from the undergrowth when the call breaks across the eucalyptus canopy, raw, raucous, and unmistakably loud. It cuts through the birdsong and insect hum like a burst of chaotic energy, building in manic pitch before trailing off into a gruff cackle. This is not a song meant to soothe. It is a proclamation, an announcement of territory and presence that leaves little room for misinterpretation. Perched high on a twisted river gum, a laughing kookaburra throws its head back, beak agape, tail twitching slightly in rhythm with its rising call. Native to eastern Australia, but introduced successfully to the southwest and Tasmania, the laughing kookaburra, Dactylo novaguineae, is one of the continent's most iconic birds. Despite its membership in the kingfisher family, it is not a specialist of streams or aquatic prey. Instead, it reigns over dry forests, suburban woodlands, and open savannas, its hunting ground defined more by clear sightlines than by water. With a body roughly the size of a crow, short legs, a large head, and a sturdy bill, the kookaburra is built for ambush and power, not speed or agility. From its perch, the kookaburra surveys its surroundings with the stillness of a practiced predator. Its eyes, dark, forward-facing and intelligent, scan the forest floor with remarkable acuity. Movement, even slight, does not go unnoticed. A lizard flicking its tail, a grasshopper leaping from one blade to the next, or a snake sliding between roots, all are fair game. Unlike many birds of similar size, the kookaburra is not shy about tackling large or potentially dangerous prey. Snakes in particular are a known part of its diet, including venomous species like juvenile brown snakes, which it subdues through repeated bludgeoning against a hard surface. Hunting begins with patience. The kookaburra often remains motionless for long periods, conserving energy until the opportunity arises. When it strikes, it does so with sudden, violent efficiency, diving to the ground and seizing its prey with a powerful bill. Smaller prey are swallowed whole after a few firm strikes. Larger or more defensive ones are battered against tree limbs or rocks until subdued. The method is crude but effective. The bird's strength lies in precision and resolve rather than finesse. Yet for all its solitary hunting behavior, the kookaburra is a deeply social species. Family groups, often consisting of a dominant breeding pair and several adult offspring, defend shared territories year after year. These groups cooperate in feeding, predator vigilance, and the raising of chicks. Subordinate birds, often siblings from previous broods, act as helpers, feeding the young and guarding the nest. This cooperative breeding system offers clear evolutionary advantages in a resource-limited environment. It allows birds to accumulate experience before attempting to breed and ensures higher survival rates for the next generation. Nesting occurs in tree hollows, often several meters above the ground. The cavity is lined sparingly, if at all, and the female lays up to 4 white eggs. The chicks hatch blind and featherless, and sibling rivalry begins almost immediately. In times of food scarcity, the stronger chicks may outcompete or even kill weaker nestmates, a grim but natural consequence of limited resources. Those that survive are well fed by both parents and helpers, and fledge after about a month, though they may remain with the family for years. The kookaburra's loud and far-carrying call is not merely an auditory flourish, it is a territorial signal, often performed in chorus by multiple members of the group at dawn and dusk. This behavior has earned them a place in the cultural landscape as a symbol of the bush itself. A familiar sound even in suburban areas where the kookaburra has adapted with surprising ease. In gardens, parks, and even golf courses, they hunt insects, small rodents, and reptiles, displaying little fear of human presence. But despite their adaptability, kookaburras are not immune to the pressures of environmental change. Habitat loss through land clearing and urban development reduces the availability of nesting hollows and suitable prey. Competition with invasive species, particularly for cavity nesting sites, has become increasingly common. Indian miners and European starlings often occupy and defend hollows aggressively, leaving fewer options for native birds. Climate shifts also affect prey availability and reproductive timing, though the kookaburra's generalist diet offers some resilience. They remain, however, supremely competent in exploiting opportunity. Observations have recorded kookaburras hunting from fence posts, road signs, and even rooftops, using artificial structures in the same way they use trees. Their behavior is pragmatic rather than instinctively rigid, allowing them to thrive in altered landscapes where more specialized species falter. In the hotter hours of the day, activity slows. The kookaburra returns to a shaded branch and rests, feathers puffed slightly to release heat. It preens meticulously, working its bill through the flight feathers, removing parasites and aligning barbs. Grooming is not vanity, it is essential maintenance. The feather structure must remain intact for flight efficiency and insulation, and the bill, a primary tool for hunting, must be kept clean and sharp. Occasionally, the bird will stretch its wings wide, ruffling its body in a show of territorial display or simply to cool itself, then settle again into stillness. Later, as the light shifts toward golden hues and long shadows stretch across the woodland floor, the family chorus begins again. The calls rise in unison, each bird contributing to the building wave of sound that echoes across the trees and valleys. It is not random noise, but a ritualized affirmation of place, bonding the group while warning rivals to keep their distance. Other birds may mimic the sound, but the power of the real chorus, the volume, timing, and confidence, is difficult to replicate convincingly. The kookaburra does not negotiate territory. It asserts it. In flight, the bird is less elegant than some of its avian counterparts. Its wing beats are heavy, almost laborious, and short glides between trees mark its typical path through the bush. But again, efficiency rather than grace is the priority. The kookaburra does not chase prey over long distances. It waits, observes, and delivers force where it counts. Its entire design, from stout build to social structure, speaks of balance, aggression tempered by cooperation, stealth offset by sound, solitary instincts shaped by group survival. As night falls and the bush enters its quieter phase, the kookaburra remains vigilant. Though largely diurnal, it remains perched in high vantage points until darkness makes hunting impractical. Its final calls of the evening fade into the background hum of nocturnal insects and the distant call of a boobook owl. In the moonlight, the outline of its body merges with the tree limb, a silhouette carved against the star-streaked sky. The laughing kookaburra is not a bird of mystery, but of mastery. It does not hide its presence. It declares it, loudly, boldly, and with a voice that has echoed through the forests of Australia for generations. And yet, beneath the laughter lies precision, patience, and power, the tools of a predator that hunts not with chase, but with certainty. In a land of extremes and adaptations, the kookaburra remains a symbol not just of the wild, but of the intelligence and resilience needed to thrive within it.